at the end of the year. So we're going to model some organic compounds using a platform called molview. And I'm doing this assignment quite a bit differently than I've done it in previous years. It's much more free form where you get to kind of structure it how you want. Okay, so this is the assignment sheet that's posted, and the instructions are on this first page, and then the stuff that you'll fill in is on the second page. So the way I've created the assignment is when you open this document, it will open a copy for you. You'll see your name come up at the start, and you can just fill in the document. You don't have to worry about editing my original. Okay, and then when you click submit, it's this document that you've been working on that you'll be submitting. Okay, so we're going to use molview. I'll open that up in a second to show you how to use it, but I want to talk a little bit about what the assignment is designed to do. So we talked about essentially 13 different sort of functional groups or types of organic compounds listed right here. Okay, so we've got alkanes. I guess I didn't really talk about haloalkanes. I'm going to trust that you guys can figure out what those are without me having to go into detail. But if you run into issues, obviously get in touch. Okay, all the way down to amides. And then I've included 2 freestyle molecules. You'll see why that is necessary in a second, but you'll be able to sort of create your own type or your own molecule if you, you'll have to do it, but you can choose whatever functional group or class of molecule you like. Okay, so your first goal is just to build 15 different molecules and name them using molview. Okay, and the first sort of 15 marks of the assignment are just demonstrating that you can correctly name and then create a matching structure for 15 compounds. Okay, the second part is among those 15 named structures, you need to complete this scavenger hunt. So I need to see instances of each of these items among your 15 examples. Okay, and some of these you will be able to use in any class of compound, like the different prefixes, but some of them only apply to certain examples. So you're going to have to go through and really make sure you've used these appropriately. Okay, so let's look a little bit at molview. So I'm going to do an example for you. Please don't copy my example exactly as part of your own assignment. So say I'm going to make an alkane. I want to use the hex prefix, so it would be hexane. But then I know that in my scavenger hunt, it asks me to indicate the location of a functional group with a number. And I also am asked to use these di or tri prefixes. So let's say I want to include a couple branches on my alkane so I can tick off some of the things in my scavenger hunt. So I'm going to do 2,4-dimethylhexane. Okay, and you want to be careful when you're creating branches, and we'll see this in the structure, that you're not actually creating a longer chain. But I'm pretty confident that if I put a methyl groups on 2 and 4, that my longest chain is still 6. But we'll double check that when we look at the structure. Okay, so this is the name. So now I'm going to open molview and visit it right here. Okay, and this is molview right here. So it automatically comes up with this 3D representation and a 2D representation. And the first thing I'm going to do, this is not the molecule I'm looking for, so I'm going to just trash that. And then I want 2,4-dimethylhexane. So that means there's a couple different ways I can do that. I can create carbon chains using this tool. Some of them, especially the ring compounds, I can just get it to generate it for me automatically, or I can just click on carbon and start. So when I click, so I've got carbon selected, and then when I click, it automatically includes a carbon. And then if I click that and drag, it creates another one. So I've got 2 carbons here, 3, 4, 5, 6, okay? And then I need methyl groups on carbon 2 and carbon 4. So I can go back to carbon 2, create another stick there, go to carbon 4, create another stick there. So that's 2,4-dimethyl hexane. Okay, couple different things I might want to do. So first of all, if you click this broom here, it will clean up your structure. So it'll resize it so that it fits the page a little bit better. And it will also, if you made any kind of wonky angles when you were building it, it'll fix those for you. I can also click this if I want to see the explicit hydrogen. So automatically I have the skeletal structure. If I click this, it shows all the explicit hydrogens. So you can see that it does include the hydrogens in the structure. It just doesn't make them explicit to keep things a little bit tidier. Okay, and then I could also click this. This is more interesting if I've got some other atoms present because it color codes them for me. Okay, but this is the basics of what I'm looking for. The skeletal structure is fine. You don't need to include the full structural diagram with the explicit hydrogens like this, although if you find that easier to understand, you're welcome to. And then I'm also going to be including a 3D structure. So I click 2D to 3D to get this over here. Okay, and then it gives you this warning, the resolved 3D structure can sometimes be inaccurate. We're not using this to like study bond angles or anything like that, so don't worry too much about this piece. Okay, we can use this, it is acceptable. The one thing I'm going to ask you to do before you insert this image into your document is to just, if you click and drag, you can move this around a little bit, and we just want to make sure we're moving it on such an angle so that you can see all the hydrogens or all the different atoms in the molecule. So for example, if I put the molecule like that, it's pretty much indecipherable. I have no idea what's there. But if I change the perspective a little bit, I can see all the atoms pretty clearly, including all the hydrogens. Okay, and then you can see there's a 1, 2, 3, 4, 5, 6 carbons in my main chain, and I've got my 2 methyl groups as well. Okay, so if you are working on a tablet, I'm working on a laptop here, so the desktop theme works well for me, but I believe if you're working on a tablet, you might want to switch over to this touch theme. Probably the interface will work a little better for you. You can also toggle how it displays. I like the automatic mode here, so I'm going to keep it like that. To include your images in your document, this is how I would do it. You could also do it using screen caps, but I just prefer to do it this way. So I'm going to download the structural formula, and then I'm also going to download the 3D model. I made sure that I had it well oriented before I downloaded it so that I can see all the atoms. And then I'm going to go back into my document. I'm going to go to structure, insert, image, upload from computer. This went to my downloads folder. I want the skeletal diagram first. Copies in there. And then I like things to be tidy, so I'm just going to crop this down a little bit so it's not so much unnecessary white space. Go. And then I'm going to insert my 3D model as well. So right here. Okay, and once again, I'm going to crop it so that there's less white space. Okay. Don't worry too much about how much space these take up. Because it's a digital submission, it doesn't matter if your assignment ends up being 10 pages long. It doesn't bother me because no one has to print it off, so you're not going to kill the forest. So this is one example done. I'm going to take this out of here, and I would like you guys to choose an alkane that's not 2,4-dimethylhexane when you do yours. And then you've got 14 more to build. I've got these 2 freestyle ones at the bottom. They might just be very easy ones if you've already ticked off all the things in your scavenger hunt. But if you found that you weren't able to do some of these in the first 13 assigned classes of molecule, then you can just make up some new structures in the freestyle rows to make sure that you've covered all your bases here. Okay? Once again, comment or email if you have any